Today we are looking at structural isomerism. And structural isomers are molecules with the same molecular formula, but different structural formula. They're having the same molecular formula, but what is different here is structural formula. So, and you should not confuse the word isomer with isotope. Isomer is a molecule with the same molecular formula, but different structural formula. But isotopes are different atoms of the same element with the same atomic number, but different mass number. That is isotopes. So, structural isomerism in alkane will be our major topic of concern today. So, let me zoom to that point. So, isomer of pentane. So, if you had some molecular models and picked out 5 carbon atoms and 12 hydrogen atoms, this 12 is gotten from multiplying 5 times 2 plus 2. As you can remember, the general formula of alkanes is CnH2n plus 2. So that's why you can see this is C5H12 pentane. So you would find it was possible to join them together in more than one way. You can join this one by one in more than one way. Yeah. In which ways can we join? We can join it in a long chain. 5 carbons. You can see in the first example. 1, 2, 3, 4, 5. So you are having 5 and H12. You can join them that way. But again, you can be having the wrong chain. You can be having the wrong chain, but up to the fourth carbon, then the last bit of this will appear as a branch. Let's look at the second example. Instead of having a wrong chain to continue, we're going to have a butane. We're going to have a butane, and the last carbon, which make it 5, will be a side branch. Will be a side branch with 1 carbon, which is methyl. And if you count this one from the shortest far end, you have it 1, 2. It is the second carbon. So you're going to have this 2 hyphen methyl butane. 2 hyphen methyl butane. Again, we can remove the final one. This one, we can remove the final one and make it a branch. If that's not the case now, if you remove the final one and make it the branch. Remember, we started with 5, the chain of 5 carbons, straight chain of 5 carbons. But we remove the last one. We left with 4 chain of 4 carbons, but we introduce some branch, methyl branch somewhere. So what if we remove now the last one to remain with 3 carbon, and then the 2 last one, the one that we remove, we add somewhere to make a branch. So we still be having 5 carbon, because you can see this is 1 carbon, 1 carbon, 1 carbon, 1 carbon, 1 carbon. In total, we are having 5 carbons. And again, in total, we are having 12 hydrogen. Yes, the molecular formula is C5H12. But what about the structure? Structure is different. First structure is pentane. The second structure is 2-methyl pentane. What about the third one? The third one, if you come from the shortest end, in this case, you can choose from any side. You can choose from the left-hand side or the right-hand side, because they're in the middle. So it's the second carbon where we have 2 branches. And 2 branches we are going to have di as previous. Di to show we have 2. But what is the nature of each branch? Each methyl. It is methyl. So you are going to have at branch 2, we have a methyl, and also at branch 2, we have another methyl. So we are going to introduce 2 hyphen dimethyl propane, which is simply read as 2,2-dimethyl propane. All these have a different structure, but if you can look deep into them, they have the same molecular structure. Because when you write the first one, is in the form of C5H12. So it's the same. This is pentane, but this is a pentane with a branch and a second carbon. So this one is also having C5H12 as the branch. Again, they are the same. The third one is not pentane, it's not butane, it's propane with two branches of methyl. And that's why you say it's a 2,2-dimethyl propane. Still, the structure of the molecular formula is C5H12. You can see they're having the same molecular formula. But what about the structure? This is a structure, protein structure. This one is a butane structure. And the last one, or the first one, is a structure of pentane. They're having different structure, but molecular formula remain the same. So that's what we call isomers. Isomers having the same molecular formula, but different structural formula. So there are three isotopes of our isomers of C5H12, which is pentane. Assuming it's continuous in a straight line, we call it pentane. But whenever you get branches, again becomes something else. There are three of them that have this molecular formula. This can be shown as either discrete formula or structural formula. Now, let us look deeply into this. Let us look at this structure carefully, as in figure 2215. You can look at this figure. So looking at that deeply, the first one have carbon, have 4 carbon and a branch. So you're looking at them deeply. Now, if we look at them deeply, you can see that you couldn't change one into the other simply by bending or twisting the molecule. Not just bending or twisting the molecule. You would have to break some bond and reconnect the atom. That's a simple way of telling that you have an isomer. Now, let's see the bond that we break. The first one carbon has 4 bonds, 3 attached to hydrogen, then the second carbon, 2 bonds attached to hydrogen, and so on. But now the last one maintain its bondage, the second one maintain. But this one, which has 2 hydrogen bonds, one bond is broken to introduce the bond that attracts to methyl. One bond from the hydrogen 2, because this was supposed to be CH. Now, because these are 2, as in this case, we break one. And when you break one, you break this one, you break this one. And when you break this one, you are going to be left with no bond. And again, that carbon will not be stable because it will be having noble gas electron structure, and so on. Now, this methyl will find somewhere where it can attach itself, where this carbon is deprived or it does take of electron to make it stable. It's where you are going to attach that methyl. That's in the case of the second one. Let's look at the third one. The third one, comparing the third and the second. In this case, you have a hydrogen carbon bond and a carbon and methyl bond. But the simple way you are going to break, you have a carbon-carbon bond here. Don't forget the carbon-carbon bond, which is very hard to break. But you can break the carbon and the bond of hydrogen, because hydrogen also only have 1 electron to offer. When you break this one, you introduce another methyl. You break it, break this bond, introduce another methyl. So as isomers appear, or as this molecule are having different structure, there is some activity that's happening. You have to break bond and to build another one. Breaking and reconnecting. Breaking and reconnecting. That's how you are going to achieve that molecular structure. So we have the straight chain without any bend. The straight chain of isomer is called pentane. We are still referring to figure 22.15. The straight chain is called pentane. The branch chain isomer is the middle one, which has a 4 carbon chain. Now, the 4 carbon chain is butane. 4 carbon chain is butane, and methyl group on the second carbon, methyl. Methyl we said is a side branch, methyl in the second carbon. So the name is going to change to be 2-methyl butane. 2-methyl butane. The final branch chain isomer, which has 3 carbon, long chain. And if there are 3 carbon long chain, we call it propane. But at the second carbon, we have 2 methyl group, 2 methyl group. And these 2 methyl group are 2, so we call it di. They are which carbon atom? The second one. So you are going to call it 2,2-dimethylpropane. Di because there are 2, and 2,2 because they are the second carbon atom. The prefix di indicates the presence of 2 identical branches in the molecule. 2 identical branches in the molecule. So now, can you find another isomers as well? I think no. For pentane, no. Because whenever you are going now to break this one, you are going to have a bent long chain. So, student frequent trading, you can find another isomers as well. If you look closer at this 4 isomers, you see that it's just 2-methylbutane rotated in space. 2-methylbutane rotated in space, as you can find the other page. So, to avoid the sort of problem, always draw your isomer so that the longest carbon chain is drawn horizontally. You draw the longest carbon chain horizontally, and now the other branches you attach to one, as you can see. Look at this, the second one, which is the longest carbon chain. Now this is not like usual, it's not horizontal, it's not this one, that is X, it's not that one, but you can see there. Then where we have branch, we have a longer chain that has 4 carbon. So this one can be altered to be written as, to make CH3 carbonated to CH2. Now instead of that corner, make it straight, CH2 CH3. Then whenever you have the branch, the only one chain is the second carbon atom, you're going to have CH3. So you may confuse, you're more confused by reading this one. You can read this one as a propane, the long chain of propane, because you can see this horizontal has 3 carbon. But now that's not the case, because now how are you going to read this side branch? How are you going to read? Get in mind, you have methyl with 1 carbon. This one is the CH2, then CH3. They are not joined. You can't say they are ethyl because they are 2 carbon. So to avoid that, always make the longest chain in horizontal manner. Make the longest chain in a horizontal manner. So when you read this one, it won't be a chain of propane, but it will be a butane. 2-methylbutane, because you have a methyl as the second carbon atom. 2-methylbutane, that one. So always avoid that to avoid confusion. Always avoid that to avoid confusion. Let's now try to look ahead. So I don't want to, sorry, due to time, I don't want to produce something else. I can say our time is much farmer, it's too much gone. It's 10:20, and some of us are doing other classes. So do you have any question on that?